All right, Military Handbook 1005, 16, Section 3, Wastewater Flow Rates, Characteristics, Introduction, Estimating Water Flow, Wastewater flow rates and characteristics is the essential step of the design. Wastewater facilities, wastewater is to be treated with exits and fake flow with a measure for the test of the wastewater. If the wastewater is to be treated with a non-existing or significant increase of the wastewater flow with the projected estimate flow of the characteristics by using data with a similar facility from the information provided by the herein and the Water Environmental Federation MOP 8 Volume 1 and 2, the Water Environment Federation MOP 858 FD5. In addition, with the conventional domestic wastewater, there are some component of the industrial wastewater discharged within the military installation, including the ship discharge, certain within industrial flow, such as the vehicle, aircraft, wash facility wastewater. Because of the unique nature of the military operation, which considerably may be intermittent with the wastewater flow, then exhibit the significant variation that must be considered with the design of the wastewater collection and treatment facility. 3.2 wastewater source for the characteristic tables used for those the typical major for the components of the wastewater carried by the sanitary sewer for the military installation. Domestic wastewater flow. The domestic wastewater is the typical component with the wastewater, both military and non-military, as indicated with the domestic water is a normal wastewater produced by the domestic activity of the people, i.e. the flow from the toilets, urinals, shower sinks, wash machines, dishwashers, etc. Source of these flows will include both residential publication, however, the military installation personnel employees will only work with the installation. In addition, with the resident of the work population may increase the periodically intermittent because of the nature of the military installation. Infloration and inflow. Infloration and inflow 1 is extraneous water with either surround water or surface water runoff surface which enter the collection system becomes the component with the wastewater flow, which is conveyed with the treated with the wastewater treatment facility. Depending on the condition of the sewer system, the flows can be have a major impact on the peak flow of wastewater to facility sizing. Table 2, type of the origin of wastewater material facilities. Military facilities. Domestic home schools, hospital, dining facilities, recreational and entertainment facilities, clubs, commercial stores, laundry facilities, barracks, offices, sanitary flow for the shower and industrial facility, infiltration, leakage of the groundwater in the sewer through the joints of the manhole foundation, drains, and damage of the defective sewer pipes, inflow, leakage of surface of the drain for the sewer through the manhole, cover the roof drains and other surface drainage, connection to industrial flow, process of wastewater facilities such as the shipboard station, rework buildings, facility shop, metal painting, plant, plating, etc., industrial laundries, laboratories, vehicle maintenance, and washing facilities, shop discharge holding tanks on ships. In some instances, repairing or replacing collection system components primarily to eliminate the reduced inflow may be cost effective. Reducing one and one will be reduced both the construction cost and the operation and maintenance cost of the wastewater facilities. However, the sewer rehabilitation projects have been reduced to the one-to-one less of the project projected, often because of the rehabilitation portion of the system results in the increase of the one-to-one at other locations, and their conservation estimated with the potential one-to-one reduction shall be used to determine the rehabilitation project is feasible. Water Environmental Federation MOP FD6 describes the methodology of evaluating sewer systems. At 1-1 potential alternative to the rehabilitation system excessive 1-1 industrial wastewater. Depending on the specific activity of the military installation, there may be source of the industrial wastewater that may be treated with the sum of the industrial activity produced with the wastewater that contains the high concentration of toxic hazards, pollutants such as heavy metals. Their pollutants might be readily treated with the conventional treatment. The process of the use of the domestic wastewater pollution prevention programs are being implemented to minimize eliminating these wastewater. Even though with these programs, some of the industrial process will still require either the separate treatment facility, some other pre-treatment before the wastewater discharge the sanitary sewer with the system. When the industrial flow with a significant scale with the pilot scale treatment evaluations may be required to determine the best method of the treatment. Additional information on the industrial process for their wastewater characteristics industrial discharge, typically with the military installation, alternative treatment methods that are provided with the technical manual 5814A 8 evaluation criteria guided with water pollution, military handbook 1005-9 industrial oil water control, military handbook 1005-17 industrial pre-treatment design demand domestic wastewater control handbook. Alright, 3231. Vehicle aircraft maintenance of the wash facilities. Washing of the oil is often performed with a detergent corrosion with inhibitors, rushing of the high pressure water rinses of the wastewater vehicle. The aircraft maintenance with the wash facilities can be a significant component of the wastewater military installation. Typical component of the water, but the main impact of the wastewater facilities and oily waste. Oily waste can be covered with the spill. Various vehicle oils and building of the drains and washing oil waters. Waste from the vehicle and aircraft, in the addition with the oil waste of the wastewater of the vehicle wash facilities may contain a large quantity of suspended solids in the wastewater are generally heavier than typical domestic water or water solids. As a result, will tend to settle when out of the collection system. To minimize the potential impact of the oil waste of the solids, the maintenance facilities, the following actions should be considered. A. Eliminate non-essential floor drains and maintenance of the bays by plugging them in, implementing oil use and recovery plans, fills for spill cleanup of the bolted items, or to dispose of the oil solid waste. If necessary, route the drain through the oil water separate and prior to the discharge of the sanitary sewer. E. Segregate waste stream and the recovery waste from where possible. When approved, implement the use of the non-persistent emulsifying degreaser, which should be minimized the emulsified oils. In addition, the substitute degrease for the hot water with a high pressure washer where applicable. To consider end of the use of the pressure washer aircraft of the vehicle to determine the maximum allowable pressure where significant of the quantity of the suspended solids are expected to provide treatment but remove the suspended solids. In some cases, wash rack wastewater reuse may be an option should be considered. 3232 additional resource. The proper design and operation for the oil wash separator is essential for the successful handling of the wastewater of the vehicle. Aircraft maintenance of the wash facility for their information for the oil wastewater. The design of oil water separators is included with the Section 5 of this handbook, Military Handbook 1005, and with the Military Handbook 11388, Wastewater Treatment System Operation Maintenance Augmented Handbook. Additional information of the wastewater discharge of the treatment tactical vehicle with the wash facilities include the Technical Manual 5, 8, 14, 9 Central Vehicle Wash Facilities. 3233, closed loop cycling. Closed loop cycling may be another option to manage wastewater for the vehicle, aircraft, and maintenance of the wash facility. There are advantages and disadvantages associated with the closed loop recycling system. Advantages of those systems include the following. Usually, recycling units are above the ground and system will reduce the risk of undetected leaks below the ground oil water separators. To further enhance the treatment of the recycling process, some of the system are equipped with the chemical monitoring injection system with introducing the collagen and the other chemical to reduce the oil and grease in the blowdown from these systems. 3. The most water recycled from the unit is over and over again. Reduce the cost of the fresh water requires reducing less wastewater with the needs to be made with the free for treatment of separate facility. Wash water reuse the conversion of the training of the solution because the majority of the cleaning solution is recycled with the wastewater. The recycling cut costs. 5. The costs associated with the permanent application fee, annual permanent renewal fees, and associated with the sampling are avoided. System reduces the risk of contaminating the environment because of the little or no discharge within the system. B. Some of the disadvantages of these systems shall be the concern for evaluating their including their following. Recycling the units require routine maintenance to ensure the proper operation of the facility. Although recycling units greatly reduce the quantity of the water waste efficiency, they usually do not eliminate these systems to produce for the most or more concentrated waste, but they may be required special management. The disposal requirements that will operate with the unit will need the characteristics of the waste sludge of the stream. C. If it's hazardous, in addition, some of the waste are routinely blow down with small fraction with the processed water to the sewer, which is made with fresh water. 3. The training with the proper the imperative the personnel must be assigned responsible and avoid from the proper operation maintenance of the use maintenance of the unit. Security, whether the protection may be becoming the factor of the machine exposed to the harsh environment. Also, the machine should be secured in some of the manner not in use to prevent unauthorized access to the possible damaged machine. 5. Closed loop recycling may not be the most economical solution. In addition, with the capital cost, significant operational maintenance costs associated with the system. Therefore, the life of the cycle cost analysis should be for use with cameras from other systems. If the more cost-effective the implementing pollution prevention measure of the pre-treat directly discharge of the wastewater sanitary sewer. Therefore, the considering use of the closed-loop system is using the following criteria. A. If the sanitary sewer is nearby, it will not be cost-effective to implement a closed-loop system. If the wash rack is already connected to the sewer, they're having difficulty meeting with the discharge requirement. The permanent monitoring requirements are typically expensive for them to obtain closed-loop system may be economically, however, the more by purpose of pursuing closed-loop system, the designer should evaluate methods of pollution prevention that would meet the discharge requirements. Finally, the water conservation aim of the issue of the activity general, given the financial incentive that would offset the cost of the system using the closed-loop system could be closed. Ship holding tank discharge. Ship holding tank discharge could be a major source of the wastewater. Military installation for the naval facility. The wastewater typically with the following general characteristics. Primarily domestic water may also contain the industrial wastewater depending on the ship operations. Be concentrated with the typical domestic wastewater because of the ship the wastewater collection system are designed. May contain a high concentration of the dissolved solids, chloride, sulfates, and sodium, and if seawater flushing and ballast systems are used. 3.3. Qualifying wastewater flow load design base. If the wastewater facility can be designed with a defined wastewater flow for the pollutant leads for the facility will need the collective treatment. It is important for the base of the design flow load, the measurement of the actual flow load of the wastewater to be treated. If unable to collect the flow load data based on the elements for the information, similar wastewater and or information included here in the Water and Environmental Federation MOPS FD4 and FD5 and MOP 8 of the Volume 1 Master Volume Estimate Wastewater flow estimate type terminology. Estimated average minimum maximum wastewater flows for property design. Wastewater facility table 3 lists the flow rates typically used in water facility design. Annual average daily flow. Annual average daily flow. Estimated the annual operating cost, chemicals and powers, etc. Maximum monthly flow. Highest monthly average and daily flow. Design of the multi-unit process, including biological process. Maximum daily flow. Highest 24-hour flow in a year. Design of certain processing units such as the settling of tanks. Minimum flow. Least instantaneous flow. Design of sewers plant conduits to avoid disposition of problems in low flows. Peak flow. Highest instantaneous flow. Design for sewers hydraulic elements of the treatment plant such as pipes and pumps and weirs and channels. 332. The flowing estimating methodology. General approach for the estimating flows. The flow of determined average of the unit flows and analysis of the wastewater discharge of the facilities being started with the average unit of the flow of the average wastewater flow of the per unit of the wastewater source. For example, the residential flow will determine the average flow per capita of the industrial flow will determine the average flow per unit of the activity. For example, the average flow per vehicle wash for the vehicle wash facility to estimate the future of the peak of the minimum flow using existing peak of the average to minimize the average flow ratio of the calculate the flow of which measurement cannot be obtained with the using data given the Water Environmental Federation MOPS FT4 and FT5 of the section individual flow components. Apply average unit to the design population production for the other applicable parameter of the installation side. To calculate the minimum and the peak flow for each of the water source, applying the aerobic flow ratio for the calculated average flow, the maximum consistent flow for the different source, to determine the total peak flow. For the consider the peak discharge of the pump station to be consonant with the peak flow for the receiving the system, unless the program of the pumping of the to be used to ensure the peak of the design can coincide. For example, the pump station equipped with the flow pace variable speed pumps can be minimized for the peak of the flows conveyed with the downstream receiving the system. In this situation, the average flow for the system are upstream with the of the pump stream to be combined with the downstream areas and the peak of the calculated with the combined average flow of the two areas. The estimated average water flows and peak of the minimum flows of the minimum normal maximum deployment conditions. Design population. If the water does not exist for the domestic wastewater flows need to be projected estimated with the both resident and non-residential design population complete with these estimated with the initial design condition for the projection of the population to be served with the wastewater facilities based on the planned expansion with the staff increase for the military installation. Determine the design resident population estimated by the adding existing proposed resident military populations and the resident dependent. For this should be included with the hospital inpatient personnel with the estimated non-residential population adding existing proposed non-residential populations which include the following people. Non-resident military calculated with the subtracting resident military from the total military strength. Civilian personnel with the civil service non-appropriated funds. Purple personnel with the other services foreign military, non-military tenant organization contractor personnel, for example, the base, maintenance and custodial, daytime schools and daytime transits. 3322 domestic flows annual average. If no wastewater data exists for determining the per capita until the flow factors calculate the domestic flows as follows. For each of estimating the flow U for the resident population 1 to 120 gallons per day capita per day or non-residential 3 to 35 to 30 to 35 gallons per capita per day. 3323 domestic flows maximum day flow. Determine the maximum 24-hour with the use of the following procedures. Multiply the annual average flow for the ratio of the maximum day flow for the average of the annual average flow based with the wastewater flow of the data facilities being used. If no data is available, to see Chapter 3 of the Water Environmental Federation MOP, the 58.5 of the FD5 of the methods of estimating typical domestic wastewater ratio of the various geographical regions. Designer caution for the carefully consider the impact of the resident non-residential populations. One-to-one installation before the restoring with the use of the data of the monograph offered by the Water Environmental Foundation MOP. The FT5 with the guidance provided with the Water Environmental Federation MOP. The FT5 is based on the municipal derived empirical data with the flow of the situation in which dry weather wastewater flow rates are expected to govern the relationship that may be appropriate for the installation. Significant non-residential populations are served one-on-one problems. For the maximum 24-hour flows of any other source of domestic flow, peak of the flow determines the peak of the flow of the residential population. Multiply the annual average flow by the ratio of the peak of the flow of the annual average flow base of the wastewater flow data for the facility being studied. If no data is available, to see Chapter 3 of the Water Environmental Federation MOP, the FT5 the message for the estimating ratio of the typical domestic wastewater design or cost and carefully consider the impact of the resident non-residential populations one-to-one installation and before the restoring of the data of the monograph offered of the Water Environmental Federation MOP FT5 And for the federal guidance provided with the Water Environmental Federation MOP FT5 is based on the municipal derived empirical data of the flow situation with the dry weather wastewater flow ratios are expected to govern these relationships may not be appropriate to installation with a significant non-residential population or serve a 1-1-1 problem in situation carefully considered allowance for 1-1 flow that must be made with developing peak design flow rate. Consider coincident peaks for the source of the non-residential population. Assume the peak flow for the 3 times the average non-residential flow with the consistent with the resident peak of the flow with the daily contribution uniform the 8-hour service shift for installation where the average domestic flow for the non-residential population exceeds 1.5 milliliters a day constitute more than 20% of the total average flow. They investigate the flow of the variation non-residential installation itself and an installation similar to the one proposed, not in the peak flow. The can vary for the specified installation of the Holbert field that was found with the residential population flows had a peak of the factoring of 3, while the base operation peaking factor approximately 7. The illustration needs to be accurately evaluated to account for the peak flows of all sources, such as the flows to vehicle and after washing facilities, any other industrial flows that occur during specific hours. If the flow coincides with the peak of the domestic flows, they should be added to the peak flows. All right, 3325, domestic flow, minimum flow. Determine the minimum of the flow of the residential population, the multiple annual average flow, but the ratio minimum flow, the annual average flow based on the wastewater flow data of the facility being studied. If no data is available, the Water Evaluation Federation MOP, the FT5 with the non-residential population, assume the minimum flow. Infloration. A typical allowance for the infloration with the induced for the per capita flow of the domestic wastewater, the allowance is 500 gallons per day with the inch of the diameter mile with 46 liters per day with the millimeter with the diameter kilometer of the sewer for existing system. For existing systems, estimated with the information comparing with the domestic water waste flow for the water using all check variation flow of the weather condition. Refer to the Water Environmental Federation MOP 58, 5D5 and 5D6 inflow. So for the drainage with the runoff with normally very in large relation with the sanitary flow. So for the drainage with the inflow should be kept with the sanitary soup with the relationship of design, rational design, adequate construction specification, inspection, and enforce regulation manual cover the large source for the inflow of the air and subject to the overflow of the surface of the drainage for the problem reduced significantly by using solid cover with a half depth pick holes. They use both bolted gasket manholes cover the areas subject with the flooding can also be reduced the problem. Existing sewer systems should be evaluated with the inflow of the designer and a new intercepting sewers, the trunk sewers, the calculator and collector sewers, the treatment facility is fed in the existing sewer. The inflow the significant source should be determined in inspecting manholes, the cut roof, and other drainage connection, smoke testing, internal televised inspection of the sewers and flow. The cost of effect of the remove that should be eliminated. The rehabilitating sewer system, prevent oversight of the new sewers, wastewater treatment facilities referred to Water Environmental Federation MOP 56. Industrial flows. Industrial flows will be based on nature activity should be estimated with the site-specific basis. Flow of the data of the wastewater to be treated with the unavailable base estimate of the similar existing activity for additional information. Industrial wastewater flows referred to the Water Environmental Federation MOP FD5 with the Military Handbook 1005-9 with the Military Handbook 1005-17. Ship discharge with the table 4 list with the maximum ship with the completement with the daily follow maximum discharge number of the pumping station, total number of the pump number of the location discharge connected to the selected ship type. When discharged with the submarines next to the tender with the tender's berth, it appeared the next ship that will discharge into the tender. Tender will discharge to the pier the rate listed before for the tender and design per sewage collection system to receive the sewage ship that include the facility to meet the total flow through the collection system. Consult with the activity of the public work department of the metering needs located with the meters necessary to provide the needed information will be determined by the layout of the collection system. With no case should there be one exceeding flow measurement meter at the shore end of each of the piers not necessary to meter the flow in individual ships. 33210 flow rate variations. Domestic wastewater flow for the military installation could be expected with the exhibit of the season while other weather influence the flow variation. In addition, with the effect of the industrial shop, the discharge flow as well for the variable nature of the military operation, the significant effect of the flow variation, the minimized flow variation, flow equalization should be considered. Equalization can be applied with the specific industrial other flow which exhibit the wide variation in the entire the wastewater flow. When estimated, consider the following industrial flows such as the vehicle and aircraft washes facilities that occur during the specific hours if then the flow coincide with the peak domestic flows, they should be added to the peak flows. Ship holding tanks discharge the flow. The flow ratio, depending on the total volume of the flow, to be handled at the time required to convey the wastewater of the treatment facility design and equalization system to equalize the flow so as to minimize the effect of the peak flow load for the conveying of the ship of the wastewater of the treatment facility at the night and the domestic flow load with will further reduce their impact. Table 4, ship sewage discharge system. Ship sewage discharge return rate. You got your maximum ship complement every 24-hour flow, gallons per minute. Table 4, ship discharges. The following provide for the equivalent ship to established Navy SEAL system, Navy Sea System Command for the shore collection of ship sewage. Ship types are enlisted from the Secretary of the Navy. Instruction 55030 1, a classification naval ship aircraft. Notes. All right, intermediate periods are increased with the youth because of the training activity of the personal mobilization exercise with the common military installation training activity of the mobilization equal exercise will create a short-term increase with the domestic wastewater with the industrial flow of these intermittent activities may result with a peak wastewater flow with the loads and in loads the faculty should be designed with a handle routine variation flow road with the flow load training without the routine exercise man with the ensure the acceptable performance reasonable operation maintenance costs. For example, the equalization system may provide the flow load of the dampening of to accommodate the significant variation facility will not be designed to accommodate the peak of the surge resulting from emergency mobilization. D. Intermittent period for the reduced flow, low flow would also be a problem. Therefore, designing the wastewater flow to be operated with efficient low over the range of flows. For example, to provide parallel trains that can be taken out of service, etc. Change the requirement of the installation measure for the design should include the provision of the expansion, contraction, or other modification measure for the more stringent and fluent requirements of the installation mission. Change of the make of the efforts to minimize the operational flexibility. 333. Wastewater loading. Wastewater loadings are typically calculated based on the projected flow of the wastewater pollutant concentration expressed in pounds per day, where it's impossible to determine the loading of the analyzed the wastewater treated with similar wastewater. 333. 1. Domestic waters. Waste. Domestic waste. An effort should be made to the measure of the planning of the design of the wastewater flow to the last resort with no wastewater data that are available to use the typical concentration of domestic wastewater for the Water Environmental Federation MOP 8. Volume 1, note that, however, there are an average data may be adjusted for regional weather effect of the collection system 1-1 before the use of the values in industrial waste. Determine the industrial wastewater characteristic, the use of the design survey, the actual waste and involved with the knowledge of the waste or similar facility for the additional information industrial waste characteristic refer to the Military Handbook 1005 and 1005-17 ship sewage. Ship sewage settles with it, well is amenable to biological treatment, but it may be septic. Table 5 will present the typical concentration of the waste for the shipboard in industrial activities do not include the high dissolved solids and chloride, sulfite, sodium concentrations applied with the seawater flushing of the ballast system. Used for information for the ship sewage, see the Navy CSS 9086T8 STM 010 CH 593 Navy Ship Technical Manual. New page. Table 5, typical sewage concentration, total suspended solids 60 milligrams a liter, total dissolved solids 20,000 milligrams a liter, chlorides 11,000 milligrams a liter, sulfites 1,500 milligrams a liter, sodium 6,200 milligrams a liter, other dissolved solids 1,300 milligrams a liter, biochemical oxygen demand 400 milligrams a liter. Effect of the wastewater, the high seawater content, performance of the high concentration seawater tends to inhibit the biological treatment. The process of inhibition if it's related with the chloride concentration of the wastewater for the new designs, absence for the pilot. Plan treatment of data with a similar wastewater to compensate with the high seawater content according to the data presented in Table 6. And analyzing the capacity existing treatment facility to receive the ship with wastewater that's figured with the design in Table 6 to indicate with the overloading solely because of the chloride inhibition conduct with the pilot plan test before the planning is expansion. Sudden change of the chloride concentration may be used the biological process to consider equalization stored with the limit of the chloride variation in the wastewater facility of 200 milligrams a liter an hour. The chloride concentration excess of 500 milligrams a liter, 5,000 milligrams a liter. All right, table 6 is your chloride inhibition, biological nitrification. Trickling or filtering rotating biological contact of 50,000 milligrams a liter, maximum chloride concentration, no inhibition. Concentration chloride success with maximum level 1. Refer to the appropriate design loading curve of the decrease and increased amount corresponding to 1 of the percent point with the removal efficiency per 1,000 milligrams a liter with chlorides in excess of 5,000 milligrams a liter. Activated sludge 5,000 milligrams a liter per decrease loading of the 2% per 1,000 milligram liter with chlorides in excess of 5,000 milligrams a liter. Aerobotic and facultative Lagoons, 8,000 milligrams a liter. Increase the detention time by 22% per 1,000 milligrams a liter. Chloride in excess of the 8,000 milligrams a liter. Maintenance of the high seawater content of the wastewater aggregated incrustations problems to avoid find the bubble air diffusion systems design orifices and trickling filter flow distribution aeration devices facility periodic cleaning of the mineral deposits using carrying selecting construction equipment materials. Section 4. Navy wastewater collection transmission system.